Okay, so we're just going to run through a bunch of examples here. If we have, well, let's start, we did one yesterday, so we'll start with one of the ones we did yesterday. Sine of 4x dx. You cannot integrate that because the only rules we have for the integration of trig functions or the derivatives is when it's x, okay? So we need to get rid of that 4x. What do I do? I know, so you just sub out the 4x, right? And then you take the derivative of that. Divide off the 4. And then you can sub it back into the integral, right? So we get our new integral is sine of u times du over 4. What can I pull out? 1/4. So now we have sine of u, which could same as sine of x. There's no other number inside the trig function. So what's the antiderivative of sine? It's minus cosine. So you get negative 1/4 cos u. Put back in what u was. Cos of 4x. And then tack on your plus c. And you're done. Now look, I'm showing every step. If you can do this quickly in your head, you'll get to the point where you can do that integral in your head. Okay? If you do enough of these. Are there any questions about that? That's like the most basic trig substitution. Yes. No. Because this, you mean this 4 here? And this one? No, because this is inside the trig function. Okay, so. All right. So what if we have this? Sine squared 3x cos 3x dx, the integral of that. So first of all, the notation, what does this 2 represent here? It means the whole sine thing squared, okay? So it means this. Now you don't have to write this. I'm just doing it just because it's our first one. That's the same thing, okay? When you get an integral with 2 trig functions, especially when they're sine and cosine, sub out, just like we did on the other ones, sub out the thing in bracket, the function in brackets that has the higher exponent, okay? So if I say u is going to be sine of 3x, what's the derivative? So we get cos 3x. Is that it? Negative. Multiply by 3, right? Because you have to use chain rule. We have a function with a function inside of it. So it's the derivative of sine, which is cos 3x, times the inside derivative, which is 3. That's what everybody forgets, is that you have to use chain rule. So my derivative is cos 3x times 3, yes. That's the antiderivative. We're doing the derivative right now. Sorry. Because on this one, if I take the derivative of cosine, that's negative sine, right? But you have to have the negative there to cancel the negative, you get that. Okay. What do I want to do now? How do I manipulate this to make it match up with something in there? Yeah, divide by 3 and move the dx up. And then that is right there. There's du over 3. That's my u. So my new integral is u squared du over 3, which is a lot easier to deal with. What's the antiderivative of u squared over 3? So it's going to be 1/3 u cubed over 3, which is really just u cubed over 9. Put back in the original function, or what u was, I should say. So it's sine cubed of 3x over 9, tack on a plus c, and you are done. Okay? So you sub out the higher trig function, the higher exponent trig function. Square root of tan x times secant squared x dx. What is your, based on what I just said, what would you sub out? Secant. That's wrong. Why is that wrong? Look at the board, right behind me. What's the derivative of tan? Secant squared. Okay, so it's not a hard and fast rule. If it's sine and cosine, yes. But if you get these other things, you got to be careful because the derivative of tan is secant squared. So if I say u is equal to tan, then du is equal to secant squared x dx, which matches up nicely. There it is right there. That's du. There's my u. So my new integral is u to the power of a half, because I don't want the square root, times du. What's the antiderivative of u to the half? Three halves, and then you divide by 3 halves, which is the same as multiplying by. Sub back in your trig. And there you go. Okay, and last one for trig. So sine x over cos cubed x. What do we want to sub out? Cosine, because when it's sine and cos, look for the one with the higher. What's the derivative of cosine? Negative sine, right? So I'm going to move that negative over. There is my negative du. There's my u. So my new integral is negative du over u cubed, which we're going to rewrite as I can pull the negative out, or you can leave it in. It's up to you. U to the negative 3. All right, what do? Antiderivative is over negative 2. So the negatives will cancel. And in fact, I'm going to flip the u down. So I'm going to get 1 over 2u squared. Plug back in u. Tack on your plus c. And there is your derivative. Or your antiderivative, sorry. Yes. If I hadn't flipped it down, that's fine. If it was like, say it was a multiple choice question on a test, I would write it like that. Okay, so you'd have to just recognize that that's the same thing. We good? Okay, oh, sorry. When you do the antiderivative, it disappears because the du is saying this is the derivative, right? Because when we're doing the derivative of this, it's du over dx. This is the antiderivative, so yes, it just kind of evaporates into the ether somewhere. Was there another question? Okay, I'll write down the questions I want you to do, but we're going to just do the next part, and then I'll give you the remainder. The next lesson is not very long. So the questions from this are page 301, numbers 33 to 41 odd. All right, we're going to move on to even and odd functions. All right. Do people remember what an even and an odd function are? Does anybody remember what an even or an odd function is? Nope. Perfect. Okay. Here is even. Says that f of x equals f of negative x. That's the mathematical algebraic way to do it. Basically, it has symmetry with the y-axis. So visually, if the most basic graph would be a parabola, so we'll just do x squared, okay? The graph of x squared, as we all know, is a parabola centered at the origin, like that. Basically, it's saying if I flip it, so if you remember math 12, negative x, that switches the x values like side to side, right? If I take this graph and I flip it like that, do I get the same graph? Yes, that's all it means. Algebraically, you would go f of x is equal to x squared, f of negative x, so you put negative inside the x. What happens if you square the negative? You get x squared. And since these are the same, you know the function is even. Okay, so an odd function is when negative f of x equals f of negative x. It has symmetry with the origin. So we will just do, we'll use the trig function sine of x. You know what a sine graph looks like? Symmetry with the origin basically means if you took the graph and you flipped it this way, boom, okay, that's what this bit is. It would be the same as taking the graph and flipping it that way. Okay? Do you get the same thing? Or you can move this over here and do both. Flip that, and then flip that way. See that dance move? Nothing. It is. Should have saved that for the superintendent. The cross-curricular. Okay. So, odd function, so sine is odd. Okay. All right. So there's odd and even functions. So what does this have to do with integration? If you know a function is odd or even, you can save yourself some work. So if f of x is even, then the integral from negative a to a, i.e., if the endpoints are the same number, but one's negative, one's positive, i.e., equidistant on either side of 0, what you can do is change one of the endpoints to 0 and just multiply your answer by 2. So for example, if we go back to our y is equal to x squared graph, that would be the area from negative a to a. Okay? Those are the same, right? Does everybody agree with those would be the same? Because it's an even function. So it's evenly, like this bit here is exactly the same on either side. So if you just integrate from here, from 0 to a, multiply your answer by 2, it's the same thing. Why would you want to do that? Why is it good? I shouldn't say good. Why is it sometimes better to write it this way instead of this way? Exactly. Zeros make stuff disappear, right? They make your life easier. So if you recognize that a function is even, using this makes your life easier. Okay? Because you're subtracting when you put 0 in, and usually everything will just disappear. All right? All right. Odd. If f of x is odd, then the integral from a to negative, or negative a to a, is equal to, anybody guess? Sorry? Minus? So if you draw that, we'll draw the picture, then you can tell me. So let's do the odd function y is equal to x cubed. You were kidding? Okay. I didn't draw this very well, but yes, it is. Now, that was not a very good. That's better. Okay. What do you know about the area below, when the graph is below the x-axis? What is this area? It's negative, right? So I'm just going to make up a number here. Say that's -1. This would be +1. So the value from -a to a of this is 0. Okay? That's the real advantage. If you recognize there are an odd function and the endpoints are the same except one is negative, one's positive, right away it just goes 0. I mean, you can do it, but you're going to get 0. You're going to do a whole bunch of work to get the same answer. So where would this actually come into play? So let's do an example here. So your first clue of when you should look for this is when your endpoints are the same. Okay? And the easiest, I shouldn't say the easiest, the most simple case is when it's going to be a polynomial. Because if it's a polynomial, you can essentially just look at the exponents to determine if it's going to be even or odd. And we know how to manipulate polynomials, right? Because if I have the integral of a polynomial, it's the same as doing the whole thing or breaking it up into the individual integrals. Okay? So we're going to take advantage of that. I'm going to rewrite this. And you don't have to rewrite it. I'm just showing you how you can do it, or sort of all the work involved. And I'm going to pair the odd functions. Actually, you know what I'm going to do? Hang on, sorry. I'm going to rewrite all the integrals. And I forgot to write the dx's on some, but forgive me for that. Fill them in. dx. Okay. So that's the same thing. I just broke them up into the separate integrals, right? Okay. So I notice that the endpoints are the same. Okay. Is this an even or an odd function? That's odd, right? So what's the answer? Done. Is it an even or an odd function? Sorry? That's an even function. It's a parabola, right? So that's an even function. So I'm going to rewrite that one as 2 times the integral from 0 to 3 of 4x squared dx. What about this? Even or odd? What's the exponent? It's odd, right? Because the exponent's 1. That's a line through the origin. Okay? 0. So that goes to 0. Next one, 6, even or odd? What's the exponent? It's even because it's x to the 0, right? So minus 2 times 0 to 3 of 6 dx. Okay, so we just got rid of 2 bits of it. We don't have to deal with those. You know those are 0. These I can actually combine instead of doing them separately. So I can just go, okay, that's going to be the integral from 0 to 3 4x squared minus 6. And then I can just integrate that. So go. You can do that, please. This is the last question. Ready for the answer? People do it? No, I haven't done it yet. 36? So we do the antiderivative of this, which is 4x cubed over 3 minus 6x, evaluated from 0 to 3, and it's 2 times that. So I leave the 2 on the outside, I put the 3 in, so it's 4 times 3 cubed over 3 minus 6 times 3 minus, and you put the 0 in. This is where it's advantageous to do the 0 instead of the negative 3, because as soon as I put zeros in there, those go away. So it's just minus 0. I don't have to worry about that. This becomes 36 minus 18, which is 18, times 2 is 36. And just to confirm it, I'll put it back up in a sec. In Desmos actually gets it right. If you do the integral of the original function between negative 3 and 3, you get 36. Okay? I mean, you could have just integrated this between negative 3 and 3, but that's going to take a lot more work. And when you're doing this, say I give it to you on a test, you don't have to show this. You can just go, that's odd, so that's 0, that's odd, that's 0. And then just pull those two and go straight to here. Okay? So you can save yourself this stuff. All right? This is just why you can do this. Are there any questions about that? You good? Here's your questions, and then we're done. You can just work on them till the presentation. 302, 69 to 75, odd, please. And that is it.